Good afternoon, everyone. So in this session, we are going to discuss why a 3D digital twin is a key component of all smart cities. So what are some of the use cases where 3D is being used? What kind of 3D content is available? Some of the tools that helps you navigate and understand our environment and how we benefit from the WebGIS architecture to easily work together. 3D GIS is used around the world in a wide variety of use cases. For scientific visualization at a global scale, for urban planning, for managing lands and sea, for underground and master planning, indoor tracking and security systems. Because 3D is intuitive, everyone naturally understands 3D visualizations, which makes it easier to work together and communicate efficiently on complex issues. 3D GIS has become essential for smart cities to manage the entire life cycle of their infrastructures and resources. It enables us to plan, build, manage, and operate assets, and augment all these processes with our latest operational data. 3D provides a natural geographic language for us to tackle issues with more realistic models, which in turn yield more applicable solutions. From reality capture to design and engineering data, we are seeing an explosion of new types, methods of collection, and sources of 3D data. There's LiDAR from drones, cars, backpacks, airplanes, and satellites, high-resolution mesh created from aerial and satellite imageries, spherical and oblique imageries from consumer and professional devices, more and more underground data as Singapore is expanding below the surface of the Earth. And we are seeing constellations of sensors all around the city. Now, how do we model a city with all this information? 3D objects are often used to model 3D cities. Buildings, trees, roads, drains, tunnels, and utilities, because each object carries its own set of attributes, like date of construction, maintenance operations, owner, cost, and so on. 3D objects are very useful when we need to interact with operational and business information. A 3D mesh represents the surface of the city, modeling everything that can be seen on the ground. So the data source of a 3D mesh is often collected by satellites, airplanes, or drones. And because generating a 3D mesh can be fast, it is possible to regularly generate a snapshots of the city that can be used for change detection and inspection. 3D point clouds collected from airborne and satellite remote sensing provide very useful information about elevation and land use, and can be used for visualization and analysis. There are other types of point clouds collected from mobile LiDAR or indoor LiDAR. Point clouds are very, very useful reference to start digitizing 3D objects. GIS is 3D and it's ready to use across ArcGIS. So you have ArcGIS Pro for powerful 2D and 3D desktop authoring, analysis, and data management. City Engine, an advanced authoring tool for urban design using procedural modeling, and many other apps to help you explore and create 3D content for the field and the office. Enterprise data and services are powered by ArcGIS Enterprise and ArcGIS Online. These two components are the foundation of the WebGIS. ArcGIS Enterprise can be installed on premises or in a private cloud, and ArcGIS Online is hosted and managed by Esri. In addition to an extensive list of 3D data formats that can be imported into ArcGIS, there are many ways to create georeference 3D models directly within ArcGIS. So your existing 2D data is an asset. Using 3D symbols, extrusions, and geoprocessing tools, you can generate 3D data. ArcGIS Pro 3D editing capabilities are growing with every new release. You now have many tools to help you edit and texture 3D objects. Drone images can be used to generate 3D mesh, point clouds, and elevation layers. And City Engine allows you to translate planning guidelines and constraints into data-driven 3D models. Esri and its partners are making more and more ready-to-use 2D and 3D content available to you. And this year, we've seen a very important contribution from Airbus, which has greatly improved the worldwide elevation layer, especially in high-rise and densely built cities like Singapore. And this world elevation layer is available via ArcGIS Online and the Living Atlas. which is also available with ArcGIS Enterprise when connected to the internet. So now I'm sure you've all heard about the collaboration between Autodesk and Esri to put GIS and Beam at the center of projects, driving smarter decisions, optimized designs, accelerated project approval, and reduced costs. I'm happy to share that designers and engineers can now bring GIS content from ArcGIS Online into InfraWorks through the Autodesk connector for ArcGIS. Content such as road, pipelines, and electrical transformers can now be directly imported based on an authoritative current geographic system of record. So all the data in the GIS comes into InfraWorks, and when the GIS data is updated, the InfraWorks models can be updated and refreshed. Singapore has made building information model part of its asset life cycle several years ago. Many buildings and other infrastructures from transportation and utilities, for example, are now being designed in 3D. So this mass of 3D data is a gold mine for a smart city which ought to record as many information as possible about its built environment. The latest version of ArcGIS Pro is making the reusability of building information easier by allowing you to directly read and import Autodesk Revit, and the process can even be automated using Model Builder or Python. I think we all agree to say that 3D visualization improves our ability to comprehend and plan our cities. It helps us measure and visualize the impact of change on an existing urban ecosystem. And to make the design process more interactive, ArcGIS is now equipped with new explorative analysis like this instant view shed in ArcGIS Pro and City Engine. Managing and planning a smart city sometimes requires us to explore what is hidden and not visible, to view inside objects or slice section of the ground. I really like this dynamic slice tool, which gives us a 3D cross-section which can be configured from different angles. And with 3D being supported on mobile devices, we always stay connected to the 3D digital city and its continuous flow of information. So when discussing with people who are just getting started with 3D, I often receive two questions. The first one is, does 3D GIS work indoor? So yes, there are many indoor use cases like indoor space management using sensors, indoor routing, tracking of assets and people, security planning and monitoring. The second question is, does it work underground? Yes, in fact, you can use 3D GIS everywhere. And there has been a lot of improvements to make navigation and visualization of underground data a lot easier, to help you manage elevation information and seamlessly explore the above and underground at the same time, because most infrastructure are located both above and underground. Now, I'd like to hand over the stage to Sean, who's going to explore a 3D view of Singapore.
Thank you, Thibaut. This is a web scene with many layers published from ArcGIS Pro. For those of you who are unfamiliar with ArcGIS, a web scene is a symbolized geospatial content that allows you to visualize and analyze geographic information in an intuitive and interactive 3D environment. The building blocks that you see here are LOD1 buildings extruded from OpenStreetMap building footprints. And the terrain is based on Esri base maps and the updated world elevation layer that Thibaut talked about earlier. Here, we are using a 3D mesh to model a part of the CBD. This 3D mesh is produced by Vricon as a native Esri scene layer package that can directly be published and consumed. We are able to get measurements using the tools provided. For example, we can get the height of a building, or we can also get the area of a plot of land. We are still over the CBD, visualizing a scene layer of point clouds also from Vricon. Point cloud classification allows us to adjust the visualization based on point attributes. For example, we could easily highlight the buildings higher than 100 meters by changing the classification of the elevation values. So by doing so, you can easily differentiate between those buildings taller than 100 meters from those that are not. Let's go to Queenstown to see what type of units are available in a private development. The legend and the color coding provides this information. To learn more about the unit, I can select it and have immediate access to other information available. Now let's take a look at the new development recently designed by an architectural firm to understand how it impacts its surroundings. The dynamic shadow visualization gives us an immediate preview of the location at different times of the day. But what we want is to measure how much shadow would be added by this onto new developments onto an existing adjacent estate. To do that, we use ArcGIS to calculate the amount of shadow cast on the building before the construction, and we then imported the architect's beam model to calculate the additional shadows. And finally, we calculate the difference between the amount of shadow being cast before and after the building has been added. We can review the underground assets to assess how this new development integrates with subsurface infrastructures, or even get an idea of the view that future occupants will have. Viewing, measuring, and calculating the impact of change enables this smart city to become more resilient to change by taking preventive actions directly at the design stage. Let me invite Thibault back to continue on the presentation.
Thank you, Sean. It was a very good demo of the 3D GIS experience on the web. Now, this brings me to one question. How do we stream such large amount of 3D data in a web browser? How do we share 3D information across systems? And we use something called a scene layer. Scene layers have been designed to rapidly stream and distribute large volume of 3D geographic content across enterprise systems that may consist of server components, cloud-hosted components, and a variety of client software from desktop to web and mobile applications. The scene layer lifecycle can be described as such. The authoring starts in clients like ArcGIS Pro and City Engine, and even 3D party vendors application generates 3D content as scene layer that can be consumed and published to ArcGIS. 3D scene layers will most of the time be published from ArcGIS Pro to ArcGIS Enterprise or ArcGIS Online. And you can consume those scene layers in ArcGIS Pro, ArcGIS Earth, web scenes, and runtime applications. And finally, maintaining scene layers will be done in ArcGIS Pro. So to summarize, scene layers are optimized for streaming large amounts of 3D data, like point clouds, 3D objects, and 3D mesh across the ArcGIS platform. The smart city is a system of systems. So from the geospatial perspective, the smart city needs an agile network of GIS. Everything is connected through a continuous flow of information. And each GIS interacts with the city by creating and receiving information to achieve specific business workflows. So the decision makers are greatly benefiting from this interconnected architecture, with the ability to aggregate subsystem information to unlock a holistic understanding of what is happening on the ground throughout the city. And ArcGIS distributed collaboration allows for such architecture. It synchronizes scene layers, web scenes, and all the content you need to share across systems through a trusted relationship. There are many exciting 3D GIS projects in Singapore. One of them is the Singapore Advanced Map from the Singapore Land Authority. It is a good example of a 3D application that integrates high-resolution 3D base map made of a rich database of 3D objects to model things like buildings, bridges, elevated highways, street furniture, road signs. It integrates DTM, DSM, point clouds, and many other 2D and 3D GIS datasets above and underground. So we're now getting close to the end of this presentation. There's still a couple of things I'd like to share with you. So this is the solution mix we've used to prepare this presentation. I would like to thank Raycon here, Singapore Land Authority, and if you want to learn more about their data, please contact me or my colleagues. Some resource links to visit once the presentation will be online. And this is a list of relevant instructor-led trainings to grow your GIS skills related to what we've discussed during this presentation. So it's really an exciting time in Singapore for geospatial professionals. There are so many new and ongoing 3D projects, and we are witnessing exponential interest in 3D GIS all over the country. So if you have questions about 3D, if you'd like to know how to get started, feel free to talk to us this afternoon or to contact us via our website. We are very keen to hear about your 3D projects and help you be successful. Thank you.